This is part 2 of a 3-part tutorial showing you how to set up a 2D platformer pathfinding system. This part's going to cover how to get all the grid points connected, and it requires you to already have all the points set up, which is covered in part 1. A link will be in the description and I code for that. With all that out of the way, let's get into it. It has come to my attention that this line is actually causing an error. The reason is because it's going to try to find the closest point and then get the position of that point, but when it's placing the very first point, there is no closest point, so it can't find that position. So all you need to add is graph.getPoints end right there. That should cause the error to go away. So now when we run this, it's no longer pulling up an error. Okay, so now that we got it placing the points, we need to connect them. So I'm going to go ahead and create another function right here, just connect points. And then I'm going to just call it here. Now those two could technically be the same function, I just want to keep them separated so that it's easier to follow along. Okay, so I'm going to go ahead and grab a variable of the points, and I'm going to start looping through the points. And these points are going to be a number like 0, 1, 2. It's going to be the ID. Right here, I'm going to create a variable closest right. And I'm going to set that to -1 because I'm going to want it to be the ID of a point. And I don't want it to be 0 because 0 could be used. I'm then going to grab the position of the current point. And this takes a point ID and passes the point. I'm then actually going to loop through it again, and I'm going to see if any are on the same height, but to the right. And then out of those ones, I'm going to narrow it down to the closest one. I'm going to need a new position. So I'm going to get the position of the new point, and then I'm going to check if that position's height is the same as our old point's position. So if new point of 1, which is going to be the height, equals US of 1, and I want to check if it's to the right, because I'm only going to check the right ones. And then after I check if it's on the same height and to the right, I'm going to check to see if it's closer to the closest right than the current closest right, or if closest right hasn't been set yet. So if closest right is less than 0, aka it's -1, or new POS of 0 is less than graph dot get point position closest right of 0. Closest right equals new point. Okay, so this should, at this point, give us the closest right at the same height. And at this point in time, we could go ahead and connect them. So graph.connect points point closest right. Oh, I called it close right. That works too. And we actually don't want to try connecting it if closest right hasn't been set, because that may give us an error. So we're going to say if closest close right is greater than 0, then the graph connect the 2 points. I just realized I want to start drawing red lines so I could see if it's actually doing it. So it probably is connecting the points, but I'm not seeing it. So I'm going to go ahead and call this inside a draw function. So instead of connecting the points for now, I'm just going to draw a line between the position and the new position. So draw line is going to be a little bit harder to set, but it's all good. Okay, there we go. So we ended up getting all the heights connected, but we don't want it to connect if there's a gap there. For example, this guy shouldn't be able to connect to this guy. So to go ahead and fix that, we're going to use the cell type function again. So we want a variable type equals cell type, and we're going to want to pass the position. But this is actually going to give us an issue, because the position we pass is going to be the world position, not the tileMap position, and the cell type is going to use the tileMap position. So we're going to go ahead and create a true or false right here. That's going to tell us whether it's the global position, and that's going to be defaulted to false, so that the ones we've already used is false. And also this cell is actually going to be above, so we also want to say is above, and that's also going to be false. So if it's global, we're going to set the position to equal tileMap world to map, and that's going to get the tileMap position. If it's above, we then want to decrease it after we get the tileMap position, or actually increase it. Okay, so that'll allow us to tell it if it's being past a global position and if the position is above the current position or the current tile. Now in here, we only want to connect it if there is no gap and no wall. So that's basically if type of 0, actually we're going to check to the right. So if type to the right is equal to 0, and all this other stuff that we added. And I forgot to pass that it is global and it's above. So now with that, there you go. So that's the result we wanted. So with those out of the way, next we want to connect the drops. Basically, this drops down this way, this drops down this way, this drops down this way. We want to let it know that it can drop down. So we're going to check if if the type to the left or to the right is a drop. Then we're going to do something based on either of those. So if type of 0 is equal -1, is going to be if the left side is a drop. Okay, so for the left drop, I could actually check if one tile to the left and down, kind of like I was checking the height this way, I could check the vertical. And I'm only going to want to get the closest because it's always going to be this one, because if it's not the closest, it's going to fall through the floor. So if I get the closest one on the left, I should be able to connect those two. So if the left is a drop, I'm actually going to want to call var closest left equals -1. Okay, so if the new position of the height equals position 0 minus cell size, so that's one cell to the left and new position 1 is greater than position of 1, and if. So this is basically going to say 1 to the left, or 1 cell size to the left, and its height is greater than or the new position's height is greater than the current point we're looking at, which is going to be downwards. Then we want to check if it's closer than the closest left. So if closest left is less than 0, aka it hasn't been chosen yet, or new position of 1 is less than graph.getPoint position close left. I'm actually going to call that left drop, because we're also going to need a right drop. So this actually works very much like the close right, except it's going to the left and checking the closest downwards. And I didn't connect it yet. So I'm going to say if close left drop is greater than 0, that means it found something, draw a line. And that's going to be close left drop. Okay, so if we go ahead and look this over, yeah, that works. Okay, I'm going to go ahead and do the exact same thing for the right drop. Okay, so I went ahead and got that to work. It's working basically the exact same as the left, except for plussing cell size and checking if it's 1 instead of a 0. So it's about this point in time you have to start considering the character should be able to jump up here, but he shouldn't be able to jump up here. So that's going to create a bit of a difference. This one's going to be a bidirectional. He could jump up or go down. This one's going to be a non-bidirectional. And to figure out the difference, we're going to go ahead and, or for this to figure out the difference, we're going to go ahead and give it a points to join. An array of points that it wants to join to the current point, basically, and a no bidirectional join, basically, another array. So right here, the close right is going to be a points to join, close right, and then we're going to just go ahead and loop the points to join. And this is just going to be point. Actually, points are declared, so we need to use a different thing. Okay, so this one, if it's less than the jump height, we want it to be by. So basically, if graph.get point position close left of the height is less than or equal to position 1 plus cell size, and then this is when we want to start considering jump height. So I'm actually going to just do a jump height of 1. Cell size times jump height. Then we want it to be a points to join. Else we want it to be a no by join. And right now it's going to be basically the exact same for a normal join and a no by join. It's just when we're doing it in the connect points, we want it to be different. And then I'm going to go ahead and do it same thing to the right side. Okay, so we go ahead and run that. It should look the exact same, but there's actually a way we could verify that it worked. If we comment out the no bidirectional points, it should get rid of all the far drops, but the low drops it shouldn't. And then also, we could increase it to see if the jump height works. So jump height of 2. We run that, and these points connect. If I increase it, jump height 3, these points would connect. So, now that we have all these points connected, there's one more group of points we need to connect. The jumping. So, if I were to jump from here to here, or here to here. Okay, so when connecting those points, I basically just need to say, at this point, if there's a point between this area, connect it. At this point, if there's a point between this area, connect it. I only really need to look up because looking down would just do duplicates, which isn't really going to cause an issue because if it tries joining points that are already joined, it just does nothing. But it will go a little bit quicker if I do just looking up. So in order to do that, I'm going to do if new position of 1 is greater than or equal to the position of 1 minus, which is going to be upwards, cell size of the jump height, and new position of 1 is less than or equal to position of 1. So basically, less than is going to be up. So if I comment this out, less than is going to be the upward direction. So that's basically saying if the height is between here or here. Now I need to check if it's also the same for the width. And new position of 0 is greater than position of 0, which is going to be to the right, minus cell size times and jump distance plus 2. So I'm going to go ahead and add a jump distance. In this case, it's just going to be a 2. And the reason I'm going to plus 2 is because I also need to include this block and this block. So the cell size times jump position plus 2, and new position of 0 is less than position of 0. And then also I need to check and see if I'm landing on a cell type that is a right. If we had this, that would prevent it from connecting this point to this point and this point to this point. Might as well only have one connection to that point. That way it gets all the way up to the edge before he makes the jump. So right there at the end, we're going to go ahead and add an and cell type of the new position, and it's true because we're using global and it's above of 1 equals -1. So if the right side is -1. Points to join dot append new point. Okay, so let's go ahead and see if that works. Yep, all the left ones looking up to the right ones. Now we just need to do it for the right ones. After getting it to show all the points and draw the right connections, we could then swap it to actually using it and get rid of the drawing. So we no longer need this, and we want to do a connect points, and then we'll call the connect points. And then instead of drawing lines, we're basically just going to do the grid.connect. We're basically just going to do grid.connect points. And then position 1, it's actually going to be point and join. Because this wants the point IDs, the draw wants the positions. And inside the no by join, you're actually going to do a false. This is a true or false, whether it's bidirectional. This is going to go from the point to the second point, which will be the drop down. So this should be the right direction from this one to this one, but you can't go from this one to this one. So that's going to be from this one to this one you could go, but you can't go from this one to this one. And you no longer need the faces. Thanks for checking out part 2. In part 3, I'm going to show you how to use this to actually get a character to move to any location in the map you want. Hope to see you there.